Good morning, everyone, and welcome back to our Hadoop training program. Right. So today we are going to continue our discussion on SDFS commands. Couple of SDFS commands we have already seen. Right. Like how do you do a put? Right. How do you create a directory and all? And we'll move forward and we'll learn more commands today. Okay. Now, as usual, we will go with the standard document, whatever we have, and we'll move forward, right? So let's get started. So I'm here on my system and I'll be sharing my screen now. All right. So let's go through this document and we need to have our virtual machine up and running. All right. So yesterday we completed till this part, right? Like how do you append multiple local files and upload that into your SDFS as a single file. Okay. Now we will talk about how do you read the data from SDFS. You have inserted some data, you have stored some data in SDFS. Now how do you get that data back, right? So the command is Hadoop Fs-get, and let's see the syntax. The syntax is Hadoop Fs-get /user sduser word3.txt. This is basically your source and this is basically your destination. Okay. Now what we are trying to do is we are trying to get the data from your SDFS to your local. In that case, source will be your SDFS directory, right? Source will be your SDFS directory and destination would be your local file system. In our case, local file system is basically the edge node, right? So as we discussed, edge node is basically a special machine which will help you to connect to your Hadoop cluster, entire Hadoop cluster, and you will trigger all your command through your edge node itself. Okay, so let's move on. Now we'll go back here. All right, so our Ubuntu is up and we'll quickly say start all.sh. This will start all our Hadoop services. Now let's look into our screen. Okay, let's go through the documents. Now this command Hadoop Fs-get can give you the data, can get you the data from your Hadoop cluster to your local file system, right? And when we say local file system, it always means Ubuntu in our case. It always means edge node in your real-time case, right? So edge node is basically a Linux box, right? So let's try this out. So Hadoop Fs-get, and I'm saying /user hduser word3.txt, which means I'm saying, hey, get me word3.txt, download that word3.txt into my local path /home/hduser. Okay. Now, if you see, you can understand that by default, right? By default, your SDFS will have a path like this /user. Okay. And by default, your local file system will have a path like /home. So if somebody creates a folder, if somebody creates a user in Linux, then the directory would be /home/that user name. Okay. But if somebody creates your account in SDFS, then you will basically follow /user/name. Okay. So that is one way to distinguish whether it is a local path or whether it is basically a SDFS path, right? Okay. Now let's try this out. So I'll go back to this place, Control L. The first thing first, what I'll do, let me check what are the files present in my SDFS, Hadoop Fs-ls. Okay, and just hit enter. It will by default give you the content of your home, right? That is /user/hduser. Okay. Now I can see I have word1.txt, I have word2.txt, but not word3.txt in my case, right? That's okay. What we will do is we'll try to bring this word2.txt into our local file system. Okay. So the first thing I'll do rm-rf word2.txt. I'm saying if I have word2.txt in my local file system, delete it. If it is there, then it will be deleted. Okay. All right. Now I know that word2.txt is present in my SDFS. And what is the location, guys? The location is /user/hduser. So please don't get confused between this. Let me just explain you on the board again. All right. Okay. So what I'm saying is when you are working on your Linux file system, okay, when you're working on your Linux file system, the default folders would look like this: /home, slash username Suraj. Okay, but if you're working on your SDFS, the folder name would be like this, slash user slash Suraj. So sometimes by looking at this name, either it is home or user, you will be able to identify whether you are actually talking about Linux file system or whether you are talking about the SDFS file system. That's not it. But I'm not saying that you cannot have slash home in your SDFS. At the end of the day, this is just a folder name, right? But usually the conventional what you see would be in this way, right? Okay, so what we are trying to do is we are trying to say, I want to get the data from my SDFS to local, right? So that's the reason we are writing Hadoop Fs hyphen get. From where to get? SDFS path, right? Where to copy those data? Into your local path. Okay. Now, if you just say here word1.txt, if you just say here word1.txt without giving a complete path name, then by default it means what? Slash user, okay, slash home. Okay, in my case SD user, right? In my case HD user and word1.txt, right? So if you just write word1.txt and if we have not given the complete path name, then by default it means slash user SD user word1.txt, right? Now local path, let's say you gave, I want to copy that into a file called word2.txt. File name can be different, right? If you do this, then ideally if you don't give any path here, then it refers to what? It refers to your present working directory. It's not it. It refers to your present working directory and it will get copied inside that. Okay, so let's have a look on it. So I'll just go back to the screen again. Okay, all right, so let's check it out here. Now what we are saying is, we're saying I want to get the file from SDFS to local. So let's go back and let's see what was the file present. ls Hadoop Fs hyphen ls, enter. Okay, now the files which are present are word1.txt, word2.txt, word4.txt. Let's copy word2.txt, right? Let's copy word2.txt. So I'll go back to this place and I'll say this. See, you have to copy word2.txt, right? So let me do it here. Hadoop Fs hyphen get. What you want to get? Word2.txt. Where do you want to get? Let's say dot. Okay, if you say dot, that means I want to get them in my current working directory. Okay, so let me hit enter. Okay, done. Now I'll say ls hyphen ltr. So if you see, I got word2.txt here, right? Let me create a folder. I'll say mkdir data 222. Okay, some folder name, and let me get inside this folder. Okay, now I'll hit the same command again. So see, I've created a folder data 222 which has nothing in it, right? So if I say ls, I will not see anything here. And let's say Hadoop Fs hyphen get word2.txt and let's say dot. Then what happens? That word2.txt will be downloaded into your current working directory, right? And if you say ls, then you will see word2.txt is downloaded from your SDFS to local file system. Okay, done. Now I'll do one thing. I'll just remove this. Okay, so I'll say rm hyphen rf star. Let me remove everything whatever was present in data 222. That means I have deleted all the content again, right? So let me try this out. Let me say, I'll say enter. Okay, and let me say ls. So this also downloaded the word2.txt in my current working directory, right? Now similarly, let me try to say rm hyphen rf star. Again, I have deleted everything. Now I'll say I want to copy this word2.txt into a file called word3.txt. Okay, and again let me say ls. Now if you see the word3.txt, the word2.txt got downloaded and saved into a file called word3.txt in my present working directory, right? So this is very important for all of us to understand, right? So the path here, the path what I have given word2.txt by default defaults to /user/hd user, right? Now this path by default defaults to /home/Suraj or whatever is the is your current logged in user, right? So that's how it works. Okay, let's move on. So let's move on to the next. Okay, now to copy the data, you have to approach. One is you can use Hadoop Fs-get, and another one is you can use copy to local. Okay, and both of them will ideally do the same job, right? And at work, I mostly prefer using put because that is get because that is very short. Okay, now as we all know that when you create your single node cluster, your Hadoop installation, whatever you have done, you might have seen there was a place to specify the replication factor. It's not it. There was a place to specify the replication factor. And what is the replication factor? A replication factor is nothing but how many times your data should be downloaded, should be duplicated, right? In such a way that if you lose any data in the middle, then also you should not have a problem, right? So the data gets duplicated and stored in Hadoop. This is what we know since day one. Okay, now let's look into this replication factor, guys. So the replication factor can be changed per file as well. Okay, and this is what is very important. You can go and change your replication factor of a particular file. So check this out. You can say Hadoop Fs -set replication factor to 2. Okay, and you can give a file name. So let me give it a try. I'll go here. First thing, I don't have word. I think I have word3.txt. Let me say Hadoop Fs -ls. Okay, so do I have word 3? No. Okay, I have word 1 and I have word 2 and I have word 4. So we want to change the replication factor of a file, right? So let me do it again first. Let me show you what is the replication factor of something. Okay, so see, this word4.txt has a replication factor of 1. Okay, and remember one thing, the directory will not have any replication factor. So whatever you are seeing here under hyphen, they are all directories. Okay, and wherever you are seeing 11111, they are all files. So the default replication factor in my cluster, because it is a single node cluster, is basically 1, right? Now what we will do is we will change the replication factor of a file word4.txt. So I can write completely word4. I can write the complete path /user sd user word4.txt, or I can directly say word4.txt as well. Both of them will give me the same output. Okay, now let me hit enter. Okay, so it says replication of 2 is set to a file word4.txt. Okay, now again let me say Hadoop Fs -ls. All right, now you check it out here. It says the replication factor is now 2 of this file word4.txt. Okay, but let me be very honest with you guys that since it is a single node installation, this replication factor will setting the replication factor to 2 will not do anything, right? Because at the end of the day, you have only one machine. Okay, so let me just erase this. We will understand how this replication actually happens. Now let's assume you have a 5 node cluster. 1, 2, 3, 4. Okay, so and let me add one more, 5. So you have a 5 node cluster here, and you want to set a replication of a file. So say you have a file called word1.txt. Let me write it big. Okay, word1.txt, and let's say this file size is say 200 MB, right? Now as per our understanding, the block size is how much? The block size is 128 because we are working with Hadoop 3, right? So this will give me 2 blocks, B1 and B2. B1 would be 128 MB and B2 would be leftover, that is 72. Okay, Now, where this B1 would be stored, B1, and what is the command you are writing, guys, here? The command which you are writing here is, the command which you wrote to copy this data into Sdfs is Hadoop Fs -put, right? And you said word1.txt, and you said I want to put it on /user /hd user, right? Done. And you have successfully uploaded this word1.txt into your Sdfs, right? That is what we have done. Now once you have executed this command, then the moment you say Hadoop Fs -ls, right, you will get this word1.txt inside this folder, inside this location, right? And as I have told you, all these locations are what? Dummy locations for a user like us. Is not it? You will not get a, when I say dummy, that means you don't get a chance to open the file physically, right? To open the file physically, all you need to do is query the Hadoop. You will have to say, you'll have to query the Sdfs, and you have to say, hey Sdfs, show me the data, right? It will give you the data, but nowhere you can do a CD, right? You cannot do CD, and you cannot say, hey, I want to go to this particular directory. That you cannot do. Okay. Now, when you did this, then what happens? This word1.txt would be broken down to B1 and B2, because this word1.txt is of 200 MB, right? And this file would be stored, like B1 would be stored here, let's say, and B2 is stored here. Done. Now, there is a technique where you can change the replication factor, right? So we have already seen that, but when you are changing a replication factor, there is one more option that, hey, change the replication factor to 2 or 3, and I will still wait till you are not done, which means I want to be 200% sure that your replication is already completed. Okay, so if you want to do that, that also you can achieve. In that case, what happens? When you say I want to replicate my data by 3, or maybe let's say by 4, then what happens? This B1, B2, let's assume the replication factor was 1 of this file, and you wanted to change it to 3. Okay, and you want to say I want to change the replication factor to 3, but I want to do this in wait mode. Okay, in wait mode, what happens? It says, okay, B1 is here, B2 is here, and then the replication will start from here, and it may be here, okay, and then it may go here, right? Similarly, the B2 will start getting replication, and the B2 may go here, right? And B2 may also come here, right? So like this. All right, so that is how the replication will happen. And there is a way where you can say, unless and until this replication is not done, okay, I'm okay to wait. So in that case, your terminal will wait till the replication is all completed successfully. So let's look into that, right? So I just wanted to explain you this concept. So let's look into that. So I'll go back and let's see this. So see here, Hadoop Fs -set replication -w, right? So this -w means wait. Okay, and I'm saying I want to replicate it by 2, and which file you want to replicate? word3.txt. All right, so if I say word4.txt, okay, now it is waiting for this word2.txt to be replicated 2 times, okay, and it will come back to us as soon as word4.txt is replicated 2 times. But as I have told you, this is a single node machine. The replication will not actually happen in this case. Okay, now what is the use of it? See, when you set a replication factor to 2, okay, and if it is a single node today, what if tomorrow one more node joins you? Then you have 2 node cluster, right? Tomorrow again one more node can join you. You have 3 node cluster. That time your Sdfs understands that this guy wanted to achieve a replication factor of 2, and hence the data would be automatically copied into some other cluster, right? But right now it will wait forever. And what is the reason? Because this is a single node machine, and as I have told you, in single node machine, even if you set the replication factor to 2, that will actually not happen. Okay, the data would be replicated only once, and that's it. Okay, so this will wait forever. There is no point of waiting. Okay, so we'll be wasting our whole time. All right, let's move on. Okay, now we'll talk about ch mode. Okay, now we'll talk about ch mode. So sometimes what happens, ch mode stands for giving a permission to users, to the group owners and all. Okay, so let me explain you that also on board, because this is very similar to what you were doing with your Linux file system. Okay, so let me go back. All right, so I'll erase this. Now let's talk about ch mode. So we have ch mode command, right? And what does it do? It basically will help you to change the permission of a file. Okay, so we will help you to change the permission of a file. So when I say permission of a file, every file in Linux has 3 category of permission. Okay, so I would say 3 category of permission. Okay, number 1, for yourself. Okay, number 2, for your group members. Okay, and number 3, for outsiders. Okay, so every file in Linux system has these 3 category of permission on a particular file, and that is basically represented as --. Okay, so whenever we create any file, for that particular file, you can set this permission, you can set this permission, you can also set this permission. It's not it, and this is called, this setting the permission can be done by using ch mode. For example, if I say I have a file called demo.txt, okay, then by default what happens, there would be ---- created, another ---- created, another ---- created, and one more dash will be created for a particular file. And what are those dashes? These dashes will actually tell you what can be the permission. Okay, so the first line would be either D or without D, and when it is D, that means it is not a file, it is a directory, right? For the file, it will not be D, it will be empty. Okay, now this is basically for yourself, this one. Okay, and this ---- stands for read, write, and execute. Okay, the first one is read, I'll write it in big. Second one is write, and third one is execute. Okay, so it's read, write, and execute. All right, now this permission, right? So see, this can take the value, of 0 or 1. Okay, so 0 or 1, only 0 and 1, only 0 and 1. Okay, so again, this will also take the value 0 and 1, read, write, execute, and this is basically for your group members. Okay, and this is basically for your others, outsiders, right? So I can say read, write, execute, read, write, execute, read, write, execute. This is the permission what you can give to all your to a particular file. Okay, now suppose I want to give complete permission to everyone, right? So I'll say I should be able to do everything. I'll say my group members should be able to do everything, and I'll say let others also do everything, whatever is possible. So in that case, what will happen? You will specify 1 1 1 1 1 1 1 1 1. Is not it, right? So you specify 1 1 1 1 1 1, right? So now in this case, if you say 1 1 1, so what is the value of it? See, let's talk binary, right? So if you say 1 1 1, the meaning of this would be 2 to the power 0, 2 to the power 1, 2 to the power 2. Okay, so plus, and this is into. Okay, little bit of mathematics, right? So 2 to the power 0 is 1, 1, 2 to the power 1 is 1, 2 to the power 1 is 2, sorry, 2, 2 to the power 2 is 4, 4 plus 2, 6 plus 1, 7. Okay, 7. So if I say here 7, that means it has full permission for others. Similarly, here if I say 7, full permission for the group member. Here if I say 7, full permission for himself. And that is the reason when you give a permission to a file, you will not talk, read, write, execute, read, write, execute, read, write, execute. All you say is, I would say, hey, give a 777 permission to a file. Okay, which means I'm saying give read, write, execute, read, write, execute, and read, write, execute. Okay. Now suppose I want my file to be executed by others only in a read mode, right? That means others can only read the data but cannot write anything into it and cannot execute the file as well. In that case, what will be your permission? You are saying I want to give only read permission, right? So see, this will look like this, read, write, execute. So you want to say this is read, this is write, and this is execute. I want to give only read permission, so make it 1, right? And these two would remain 0. So how much it would be? 2 to the power 0, 2 to the power 1, 2 to the power 2, right? So see, 2 to the power 0, 2 to the power 1, 2 to the power 2, right? So now this would be 0 because here you have 0. This would be also 0 because here you have 0. And 2 to the power 2 is 4. So you will give a permission of 4. When you give a permission of 4, so that means you will give a permission of 4 only, right? So your file will have a permission like this, 774. And if you say 774, that means I can do everything, my group member can do everything, but outsiders can only do read, right? Only can read the file. So that is how the permissions are set in your Linux file system. The same concept holds true for your SDFS as well. Okay, and why do you really need this CH mode? Give me any reason. Okay, I'll give you a reason why do you really need this CH mode. Okay, this is a practical problem you will face when you are working on Hadoop. Okay, now see, whenever your Hadoop job runs, it could be a Spark job, it could be a MapReduce job, or anything. Okay, what happens, in the production there will be a special guy. Okay, there would be a different user altogether. You see, at the end of the day, when you are working for a company at production level, right, nobody would be interested to know your name, right? So what we do is we always have one or other user using which we run all our production job, and that user is not a real user. Okay, that user would be just a bot user kind of thing, right? So like company has given some user. So for example, let's say if you're working for ICICI, maybe ICICI underscore bot, possibly, okay, or maybe loan underscore bot, right? Some user, okay, which is really, they do not exist, but they are system level users. Okay, now suppose you have a job which got executed using a bot called loan bot. All right, done. Now what happened is it has written a data into this place, slash user slash, now not SD user, loan bot. Okay, and there is a file, let's say result.txt. okay, now who has written this file, who has created this file? This file has been created by loan bot, but the permission for this file could be 770. The permission of this file could be 770. Okay, which means loan bot can do everything, the group members can do everything, but others cannot do anything. Okay, and let's assume your user slash HD user is not a part of the group. Okay, so he's an outsider here, right? Now you have processed this data, and then you have got this output, and you would take this output in the downstream application. You will go to some place, you click on a button, and that, when you click on that button, that starts consuming the data from this place, let's assume, right? And all of a sudden you realize that the data which was processed was not correct. Okay, the data which you were processing were not correct. The people, the team who are responsible to give you the perfect data was actually not, they did not give you the perfect data. Now what will happen? Since this data is not perfect, your downstream application cannot consume it. It's not it cannot consume it because it will consume the wrong data now, right? So maybe your team decided, okay, we will not take this data forward. Okay, let us take last week data. That's absolutely fine. That's okay. So you have come, you came to a conclusion that this file will not work anymore for us because somebody has done some mistake while processing the data, given us the wrong data. And but we definitely have to push this data. We definitely have to push this data because along with this data there are some other files also, right? So all other files will go perfect, but only this file has to be replaced. Now if you want to replace this, then what will happen? This location is owned by loan board only, and you are not a member of it, right? Now if you are not a member of it, then you will not be able to get rid of this result.txt. You cannot remove this data because you are outsiders, right? So you cannot even read this data, right? And that is the reason you need this chmod, right? So that you can do a chmod on this result.txt and read the data and change the permission. Of course, to read the data, to change the permission, you must have a privileged, you must have a valid token of a loan dot board. You cannot simply go and change the permission if you are not that guy, right? So otherwise you need a permission, like you need to have the credential of this loan board so that you can go back and change the permission of this file. And once you change the permission of this file, what you can do, delete this file and then upload the new file, right? Or I'll say give the whole read write execute permission 777 for some time in this folder, to this folder. Once you give the permission here, anybody can do anything, right? So just make your changes and immediately revoke the permission of 7 to 0 only. Okay, I hope you understood the concept. Let's do that. Okay, now we are here. So the Hadoop chmod command is used to change the permission of a file, right? And -r can option can be used to recursively change the permissions of folders and subfolders and so on. Sometimes what happens, I have a main folder, data folder. Inside that there are so many subfolders. Okay, and I want to say, hey, I want to change the permission of this folder as well as all its subfolder recursively. So you can say -r. Okay, and let's look into this command. So the command, if you see this command, Hadoop Fs -chmod -r, which means recursively, okay, if possible recursively 770, okay, and this is the permission, which means to myself I should be able to do everything, to my group members they should be able to do everything, but outsiders should not have any permission, right? And then we are saying /user/sduser word3.txt, which means change the permission of this file to 770 so that once the permission is set, I can do anything, my group member can do anything, but outsiders should not be even able to read the content of that file. Okay, so that's what we have. So let's do this and copy this and let's say paste. Okay, and here I'll have word4.txt, enter. Okay, now let me say Hadoop Fs -ls word4.txt. Okay, now see this. Here you can see the permission, right? Read write execute, and there is nothing over here. Okay, what if I want to give a write permission to others but not read, for example, right? So see, read, write, execute. So this is 1, this is 2, this is 4, right? So I want my second dash to be activated. So let me go back to the board. 1, 2, 3, right? Only 1, 2, 3. Now I am saying this is read, this is write, and this is execute. Suppose I want to give a permission of write only, right? That means you have to enable this flag. to 1. This would remain 0 and this would remain 0. So what is the total value? 2 to the power 0, 2 to the power 1, 2 to the power 2. The total value is 2, right? So 2. So in order to make writable, what you need to do is you need to say 772, right? And again you say ls, and you'll see others can also write, right, in this place, right? So others can also write in this place. So that is how you can change the permission of a file system, right? So you have created a file, you have executed a job, and the job output is stored in some particular directory, right? And then you are going on leave for 2 days, and you want your teammate to take care of your result. So what you do is give some permission, maybe 777 permission or so, and say, hey dude, here is the data you have, and I've given all the permissions, and then you can easily do whatever you want. You can read the data as well as you can edit the data if required. Okay, and when I say edit, I'm not talking about a VI edit. Okay, so we'll talk about that also. All right, now let's move on to the next. Hadoop Fs Chown, CHOWN. Chown stands for change owner. Okay, whenever you create a file, you are the owner of that file. Okay, but you can also change the owner of that file so that you can transfer the ownership to somebody else. Okay, now where can you use this concept? Now, for example, I have created a file. Okay, I have created a file in Sdfs, and every time one or other colleagues are pinging me, hey, give me this, give me that, give me this from this content, give me that from that content, and do these changes here, do that changes here and there, right? And I will definitely get frustrated by taking up all the requests, right? So I will say, wait, let me change the permission, let me change the ownership of it. There are two things you can do. One is you can either give read write execute to everybody so that everybody can take care of it, but you are still the owner. Okay, you are still the owner. Now if you are still the owner, then every new guys may come and ping you saying that, hey, I also want to be I also want to do something on this file, can you also give me permission? If I assume that you have not given 777 to everyone, because you will not give 777 for any file, right? Giving 777 to your file means anybody can access, right? And let's assume you don't want your data to be accessed by anybody. So whatever whoever is coming to you for file access, you are giving them one by one. Well, let's assume. Okay, now you are working on a project, you had some piece of files, and now let's say you are getting released from that project. So if you're getting released from that project, why do you even want to own that file, right? Not really required. So you will say, okay, I will change the ownership of this file to some other guy, right? To somebody else. So when you do that, then what will happen? Even though you have created a file, you have changed the ownership, and now you don't own that file anymore. That file is owned by somebody else. Okay, and what is the command? The command is chown. Let's see this. Hadoop Fs hyphen chown, okay, hyphen r, recursively. Okay, recursively do this for every files and subfolders present inside that. And I'm saying this file _word3.txt, I want to change the ownership from myself to one more guy called Suraj of supergroup. Okay, so this is basically a group name. This would be a group name, right? So whenever you get one account on your edge node, you can see you will be assigned to a group. Okay, and when you are changing, when somebody is giving you the like ownership, when somebody is changing the ownership of a file, they have to mention to which guy you want to change this ownership, and this guy belongs to which group. Okay, so doing this will change the permission of word3.txt to a guy called Suraj, and he belongs to supergroup, right? So the ownership will change from SD user to Suraj. Let's see this also. Copy this and let me go here. Okay, now the first thing I'll say, let me see word1, so word4.txt. So see here, right now, who owns this file? SD user, because it was me who created this file by logging into SD user, right? Now what I want to do is I just want to execute this command, okay? And I'm saying word4.txt, okay? And I'm saying I want to change my ownership from SD user to Suraj of super user group. Okay, so you have successfully changed the ownership of yourself, and then you can just relax, right? It's just like you want to sell your car, and when you sell your car, you really don't want to take a headache of all the fines and whatever happens to the car once you have sold it off, right? So you basically change the ownership of it, and then you say, I don't care now what happens next, right? So that's where you can use this command Hadoop Fs chown, okay? And all these commands what we are learning, chown, chmod, are from Linux, okay, are from Linux, and that's the reason I always prefer using Linux to learn big data. Okay, let's move to the next one, Hadoop Fs Copy. Okay, now sometimes you want to you would be interested to store a file from one location to another location. You want to copy the data from one location to another location within the same cluster. Okay, in that case you will use cp command, Hadoop Fs -cp. Right, now can you give me an example where exactly you will be using this? So let's assume you have executed a job, and that job has given you output in one location, okay, and you are going to do some POC on that particular output, and you know that that particular output is basically a temp location every time, okay, and you know that your team I mean your like admins, they have configured the system in such a way that all the data from temp which are older than 15 days will be cleaned. You want to store that data into some other place also, right? So what you'll do, you'll say Hadoop Fs -cp, right? Now let me give you a practical sense of it. So I'll say Hadoop Fs -ls / okay, now look into this. I have slash data234 / tmp / user / word2.txt / word data. Let me create a folder here, Hadoop Fs -mkdir -p / tmp / I would say job output enter. Okay, now I have created a file, I have created a folder called job output inside my /tmp. Okay, let me copy some file to it, Hadoop Fs put word 3.txt to /tmp /job_output. So I have copied word 3.txt into my folder, inside my folder job_output. Now let me say Hadoop Fs ls /tmp /job_output, right? So we have word 3.txt, and this is present in your Sdfs, right? Now this is present in your Sdfs. Now what you want to do is you want to copy this file word 3.txt which is present inside your temp job output to your location, okay, but you don't want to move it, you want to maintain a copy of it because other teams are also using this file from this location right now, and you want to just keep it with you somewhere, right? So what you can do is you can say Hadoop Fs -cp. So the command would be Hadoop Fs -cp. What you want to copy? You want to copy this. Okay, where do you want to copy? I want to copy it in, right? So you are trying to copy the data from one one cluster to the same cluster, right? So you are trying to copy the data within the cluster itself from one location to another location, but within the same cluster. So in that case, you will say Hadoop Fs -cp and source and the destination. The source and the destination would be the same cluster. Once you are done, your word 3.txt would be successfully placed inside /user SD user location. Okay, let's see that. Hadoop Fs -ls /user /sd user. right? So now 𝗏3.txt is also present here because we have just copied it from some location. That's where you will use Hadoop Fs-cp. Okay, let's move on. Now look into this. Hadoop Fs-cp / user sd user 𝗏3.txt. This is basically a file, and you want to copy this file under this location. Okay, so it will check data1 is a folder. Okay, data2 is not a folder. So if it is not a folder, it does not create a folder for you. Okay, so if it is not a folder, then what it does is, data1 is a folder, and inside that you want to copy, inside that you are actually targeting to create a folder called data2, but that does not happen here. What it does is 𝗏3.txt would be copied to a file called data2, okay, and data2 is a file here and it is not a folder. Now if you want to see that, what we need to do is first Hadoop Fs-ls. Let's see the content. Okay, now there are too many data, so let me just say Hadoop Fs-rmr, okay, and I'll say data star. All right, they are all deleted now, and I'll say Hadoop Fs-ls. I've deleted all the folder that starts with data because of too many files, right? Now what you can do is you can just give it a try. So let's create a folder. Let's try to execute this as it is. Okay, let's try to execute this as it is. All right, now look into this command. Look into this command. Here I'm saying Hadoop Fs-cp / user sd user 𝗏3.txt. 𝗏3.txt is here, and I'm saying I want to copy this into a folder called data1. Inside that I want to copy it into data2. Okay, let's hit enter. All right, now what it is saying is, hey, you want to copy the data into data2 inside data1, but your data1 does not exist, right? And that is a problem here. So what I should do basically is I should say Hadoop Fs-mkdir, and let me create data1 folder first. Done. Now I'll go back and I'll hit the same command again. Okay, this time it did not give me any error because data1 is already there, and in this case data2 did not exist, right? So there is no folder called data2. So here 𝗏3.txt content will be copied to data2. Data2 is a file in this case. Say this. I'll say Hadoop Fs-ls data1. So data1 contains data2, and this data2 is not a directory, it is a file in this case, right? Now what I'll do is I'll say Hadoop Fs-rmr data1 / data2. I'm deleting my data2 file. Done. Now again I'll say Hadoop Fs-ls data1. Okay, my data1 file does not have anything. Let me say Hadoop Fs-mkdir data1 / data2. So I'm creating a folder this time. Okay, so please mind this. I have created a folder this time. So data1 contains a folder data2. Okay, now what I'll do is I want to run the same command here. Okay, I'm saying I want to copy the content of 𝗏3.txt inside data2. Let's see what happens. Okay, something happened, and let's see what is present in this data2. Right, so in this case what happened, 𝗏3.txt was created, right, as a file inside your data2 because data2 is basically a folder. So that is what I wanted to tell you here. Okay, so see, the below command copies the content of 𝗏3.txt in / user sd user data1 data2 file. Data2 is a file here and not a folder. Okay, now I would like to add, yeah, so see the next command creates a file called 𝗏3.txt under data1 / data3 folder, fails if data3 folder does not exist. So if it is a folder, then inside the folder file will be copied. If the folder does not exist, and if you give it like this, then if data2 is a folder, then this file will be copied inside the folder. And if data2 is not a folder, then the content would be copied into a file called data2. Okay, and that's how basically your Hadoop Fs-cp command will work. Okay, next. Now you can also do multiple copy at the same time. For example, see here, let's look into this command. Okay, Hadoop Fs -mkdir data. So what it will do, it will create a folder called data. Hadoop Fs -ls. Okay, do I have anything called data? No, I have a folder called data1 but not data. So let's say paste. I'm creating a folder called data. So data folder is created. Let's go back. Now I'm saying Hadoop Fs -cp copy word1.txt, word3.txt inside your data folder, right? So let me copy this to, before I do this, Hadoop Fs -ls. Let me see what are the content present here. Okay, I have word1, word2, word3, word4. So now what I'm trying to say is, I'm saying Hadoop Fs -cp, I want to copy word1.txt, word3.txt to data folder. Okay, so what happened is word1.txt, word2.txt, both of these files got copied into data folder. Okay, now let's say Hadoop Fs -ls data, right? So you are able to see word1.txt and word3.txt are copied here. Okay, and that's how your copy command will work and will be able to copy the data into the destination, right? Similarly, you can also say Hadoop Fs -cp and you can give a wildcard here. You can say I want to copy all those files which starts with word, right? And I want to put it into my data folder. So see here, I have given it, I have written it this way. You can write it like this. You can just write /user sd user data. You can also write data. So these are all the formats. Again, now check this out. Hadoop Fs -ls data will give you the content of data file, data folder. This is what we have done exactly at the top. Okay. Now instead of just writing data, you can also write the complete path /user /sd user /data. Okay, again you can also do it like this: sdfs colon localhost 9000 /user sd user data. This is also valid. Again, you can also say sdfs colon // without writing this localhost and 9000. Okay, I've just removed localhost and 9000 and everything is same. So what I'm trying to tell you is all these 4 commands would give you the same output. Now again, instead of Hadoop Fs, you can say SDFS, DFS -ls and anything out of it, right? Anything from this 4, right? All of them will give you the same output. Okay, so let's get back to discuss more SDFS commands. Now the next is Hadoop Fs Get Merge. Let's see what exactly it does, right? So Hadoop Get Merge command concatenates the file in SDFS and gets them into a local file system. So suppose you have like couple of files in SDFS and you know that both of them contain the same data, right? And you would like to merge them and get them downloaded in your SDFS. So you can use a get merge command. Okay, so let's see how does it work. Now to understand this, what we have to check is we have to check if we have fruit and sports data in our SDFS. That is what we had added here. That is what we had uploaded yesterday, right? So Hadoop Fs -ls. Okay. Now I have fruits and I have sports. This contains some data, right? Okay, these are basically directories in this case. Now these are basically directories, D and D, and the size source 0, right? So inside fruits, let me go inside fruits. CD, not CD, sorry, ls fruits. Inside fruits, you should have the data of fruits.txt, and inside sports, you should have the data sports.txt. And these files are this file contains some information, and I want to download both of these files together, but I also want to copy the content of these files, right? So the first thing first, I'll say show me the content of sports dot anything, right? So it will show me the content of everything, and I can also say show me the content of fruits, right? So if you can use cat or you can use text also, so both of them will give you the same output. One major difference between this cat and text, what I have seen is your text has the capability to read the data from a sequence file as well, Okay, when I was working with one of the biggest client, uh, we used to have the data in sequence file format. Okay, and your Hadoop Fs -text can give you those data as well. All right. Now, okay, so now let's move on. So you have a sports.txt file, you have fruits.txt file, and you want to get those data merged and downloaded into your local file system. So now the command would become Hadoop Fs get merge, and then the first file name. So I'll say sports.txt. The other file name fruits.txt. I think it was sports. And where do you want to store this file? I want to store this file in fruits_sports.txt. So what we have done so far is we have copied the content of sports and fruits.txt from Sdfs and merged them together into our local file fruits_sports.txt. Let's see the output. So I'll say ls-ltr. See, you got fruits_sports.txt, and you can just say cat fruits and sports.txt, and you will see you have cricket, football, hockey, apple, banana, mango, right? So first sports came and then fruits came, because while you were doing this operation, first you specified sports and then you specified fruits. So the content of sports.txt, the content of fruits.txt would be appended and would be placed into a new file, and that file would be downloaded into your Sdfs. Okay, next, this is very important concept called 𝗙𝗏. Okay, this is very important concept called 𝗙𝗏. Now by default the 𝗙𝗏 is not enabled in your Hadoop cluster. Okay, when you do your single node installation, by default your Hadoop cluster will not have a support of 𝗙𝗏. You will have to enable it. Okay, now what does this 𝗙𝗏 do? 𝗙𝗏 will make sure that it will preserve the data. Okay, when you delete the data from your location, it will move the data into your 𝗙𝗏 so that you can get them back in case you accidentally remove that data. Okay, sometimes it happens that while I wanted to delete one data, I might have mistakenly deleted the data of a client, right? It is possible. So if you do that and if you have 𝗙𝗏 enabled, then you can thank yourself. Okay, sometimes it happens. I feel that okay, I've given a proper path, but then I realized that this path was basically not a staging path. This path was a production path, and what will happen? The data will be gone, right? But thanks to the thrashing concept, that if you delete the data, it will go and reside in your 𝗙𝗏, right? So in order to enable that 𝗙𝗏, what you need to do is you need to edit your code site.xml, right? So if you have already completed the installation, I hope you understand what is this code site.xml. It is an XML file where you can put some configurations, right? So sudo vim is how you will edit your files, right? /user local Hadoop etc. Hadoop code site.xml. Inside this, you just have to specify this property. Okay, you'll say I want to set a property called fs.thresh.interval whose value would be some number. Okay, and here I've given a number 10080. And why this number was given? Here we have given a value equal to 10080 means 7 days. 7 into 24 hours into 60 minutes will be this value. Okay, now this will make sure that whatever data you put on your 𝗙𝗏 will be preserved for 7 days. Okay, now once you have set up this 𝗙𝗏, then you need to restart your cluster. Okay, so you restart your cluster. After that, when you do Hadoop Fs -rmr, you will see a message like this. This is sent to .thresh folder. Okay, this is sent to .thresh folder, and that is the reason if you see whenever I delete data from my file, my Sdfs, it always shows me that the data is moved to the 𝗙𝗏 folder, but you don't see them because by default it is not enabled. You have to enable it. Okay, so let me go back and do the same thing here. I'll say Hadoop Fs -ls. Okay, and let me delete data folder. Okay, so I'll say Hadoop Fs -rmr data. I'm deleting data folder. Okay, so see here it says this file, data file, is moved to .thresh current user SD user data. So if you see this path, this data is present inside my /user SD user data, right? And that is moved exactly on the same hierarchy. Okay, the way it works in your Windows, right? For example, you want to, if you delete a folder, that folder directly goes and sit inside your uh, thresh, inside your recycle bin, right? However, there it does not create the directory structure, right? But here it goes and creates the directory structure, and it stays wherever it is supposed to, right? Otherwise you would have directly seen a data folder here, right? But this is how it is, right? So the location from which you delete, okay, the location would be preserved when it is there in your thresh, and from here you can again move it back to your place if you want to do so by using Hadoop Fs copy, or move also can be used. Okay, next, now if you have this data and you want to bring this data back, what you can do is you can say Hadoop Fs -move .thresh/current user SD user data, right? So this is basically the folder which is there in your thresh, and where do you want to keep it back? Onto your current working directory, right? So this will give you the data back to the place where you had them earlier. Okay, now sometimes you may not want to store the data in thresh. You may be interested to delete it straight away. Okay, and one such use case is you are running a job, and that job gives you the output file, and those output files are very huge, very large. Okay, and let's say you have executed a job and it ran the whole midnight and it gave you the output, right? But then in the morning time you realize that there was a mistake, you've done some mistake, and your output file, whatever you have achieved so far, is no more valid, right? So if it is no more valid, then you would definitely like to delete that, right? You would definitely like to delete that, but at the same time you don't want that to be placed in the thresh folder, because at the company level, every file, whatever you are putting on your SDFS, anything, right, the size of these files will be monitored. Okay, the size of this file will be monitored, and then you will be sent an email, hey, your folder is exceeding this, right? So it is always better that you can also, it is always better to remove the data from the thresh, okay, if you feel that it is really not even required, right? The way we delete our recycle bin is not it. So if you want to delete the data, then there is a command called skip thresh. So let's look into this command. Okay, let's look into this command. So here what I'm trying to do is I'm saying Hadoop Fs -rmr -r skip thresh data, right? So here I'm saying I want to delete the data folder, but this data folder should not even be stored in your thresh, right? So it did not work because data folder does not exist. So let me say Hadoop Fs -ls, and we'll do a skip thresh with some other folder. So I'll do it with data1 folder. Okay, now see it says deleted data1, and it did not give me that message saying that data1 is successfully moved to thresh, because you are saying I don't want to preserve this data under my thresh. Now we have a command called Hadoop Fs move from local. Okay, and let us understand what does it do. We discussed this, right? We discussed this. Move can be used to move the data from one location to another location within the same cluster. Okay, now the Hadoop move from local command moves a file from local file system to SDFS directory. We have used Hadoop Fs -put, is not it? Similarly, you can also say Hadoop Fs -move. In that case, what will happen? See, put will copy the data, okay, but move will move the data from local to SDFS, and at the same time will delete the data from the local source. Okay, like you can say it is a cut paste, right? So you cut the data from the source and you paste it into your destination. That is what move from local will do. Okay, now to understand this move from local, what we will do is, let's go to this place and let me remove everything, rm-rf star. Okay, I'm inside data 222, right, folder, and let me create two files very quickly. I'll just say apple ball, and I'll paste it on word1.txt. This will create a file called word1.txt, and again let me create another file, word2.txt. okay, and then what I'll do is I will fire this command word1.txt to, see, I'm saying Hadoop Fs -move from local word1.txt to a current directory in my Sdfs, right? So instead of that, I can say /tmp, right? Because I also have /tmp folder in my Sdfs. So what it has done is it has moved word1.txt. So let's say ls. See, word1.txt is gone, right? Now similarly, I can do. Let me do one more thing like this. I would say copy word2.txt. okay, and I'll say word3.txt. so what I'm doing is I'm copying the content of word2.txt into word3.txt in a local file system. This is only cp command, right? So again, if I say ls, I'll get word2.txt and word3.txt, right? Because word2 and word3 are exactly same. So we have word2.txt, we have word3.txt, and they are all they are present in my local machine, right? Now what I'll do is I'll fire this command. I'll say Hadoop Fs -move from local, and I'm saying word2.txt to be moved to word3.txt. So let's see what does it do. Let me make it 4 so that you don't get confused, or let me say 444, okay, so that the file does not exist. Okay, something happened. Okay, now let's see what happened exactly. See here, word3.txt is gone, right? word2.txt is gone because of this. Okay, and it is copied and it is basically pasted to a file called word44.txt, right? So if you say Hadoop Fs -ls, you should see word44.txt, right? And this contains the content of word2.txt, and it is completely moved from the local file system. Now it is important to say, let me copy again, copy word3.txt to word1.txt. Okay, I've copied this, done. Now I want to do like this. I would say Hadoop Fs -mkdir. Let me create a folder called data123. Okay, I have created a folder called data123. Done. Now what I want to do is I want to see if I say word star.txt, okay, and I would say I want to move them to /tmp /data123. okay, look into this command. I'm saying Hadoop Fs -move from local, okay, and in the local file system currently I have word3.txt as well as word1.txt. okay, I have both these files here. If you want me to show you, I will show you that, but let me copy this command, copy this, and say Control U and say ls. Okay, so when I say ls, I have word1.txt and word3.txt, and I want to trigger this command now. I'm saying word star.txt, move this to your data123. Okay, now let's say ls. Now if you see, everything is moved, right? So the copy from local is similar to put, but what it does is it is basically cut and paste, right? And it's not copy and paste. I always prefer using put because that is always safe. I feel I'll copy the data completely first, and then if I feel I should delete it, I'll delete the data. Okay. All right. So let's move on. Next, we have Hadoop Fs Mv Move. This move can be used to move the data from one source to the destination within the same cluster. Okay, now look into this. Hadoop Fs -move word1.txt to word2.txt. This will basically rename the file. Okay, now again Hadoop Fs -mkdir word count. So what I'm doing is I'm creating a folder called word count in my Sdfs, right? So let's do that. Say paste. Okay, so what we are doing here is we have created a folder called word count in my Sdfs. So Hadoop Fs -ls should also give you word count. I have a word count folder here. All right, next, now I want to say Hadoop Fs-move word2.txt, word3.txt to your word count, right? So I've written it in a long way. Okay, instead of that you can also do it like this. You can say first Hadoop Fs-ls, let's do. Okay, now see, you have word 1, word 2, word 3, word 4, word 4, 4, right? All these are the txt files. So I can say Hadoop Fs-move what? Word anything dot txt. Okay, where? Word count, right? So instead of word count, you can give /user/sd user word count. So this has moved all the file from this location to that location. Hadoop Fs-ls. You do ls. Now you will not see this word 1, word 2, word 3, word 4, which you were seeing earlier. See, all these word dot star are moved inside your word count. Now you can say Hadoop Fs-ls word count. Right? So all the files which starts with word are all moved to a folder, to a special folder called word count. Next, you can also do it like this. You can say Hadoop Fs-mkdir opt. This will create a folder called opt. Okay. Once it is done, you can say Hadoop Fs-mv move, right? And you can say from the word count folder, there is a file called word3.txt. I want to move this to word4.txt. Okay. But one thing I would like to tell you guys, that when you say move, that just renames the file internally, because see, I have already told you that all these file paths are all dummy things for us, right? For the programmer, right? For the people who are just using Hadoop, internally they will be stored somewhere, and when you just say move, don't believe that the data will move. Data will not move, is not it? It's just the registry will be maintained, that okay, these blocks would be now referred by this location. Okay, these blocks would be now referred by this location. Earlier the location was this, and now the location is this. The file will not get moved.